Hello. Good morning. Have you all heard about AI? It's been in the news, just a little bit. Cool. Okay, so this famous photo, that one, was taken about 1970, right? And it shows Ken Thompson and Dennis Ritchie, and they're inventing Unix, right? There's probably a lot of their work in every device in this room. And they're doing it on a teletype machine, right? Which at the time was the best interface for writing software because what it replaced was punch cards, like holes punched into cards to record ones and zeros. And one card would be 80 columns wide, and you'd treat each card like a line of code. And you'd write your code first on paper, and then when you were happy with it, you'd have to manually punch it into these cards one by one until eventually you had a program, right? A whole program. And you'd keep it in something like a shoebox, and you could write helpful notes for yourself on the side of chunks of it to describe what that logic does. Now, this photo of the teletype 50 years ago was not the dawn of software development. It was a huge upgrade because it was the first direct, low latency interface between programmers and computers. You could just type into the machine to create software, and the machine would type its output back to you. But you still had to author software line by line, right? The editors in the day of the teletype were actually line editors. You would ask it to print line 53, and then you would carefully craft the perfect edits to that line. And because each round trip with the computer consumed ink and paper, you wanted to be very intentional about what you were doing. You didn't just want to mess around. And when we finally got CRT terminals, that cost disappeared overnight. But it took a while for editors to figure out what this new tech was good for. At first, they worked exactly like line editors, right? Except you could see more lines. So it was great, I could see more lines, but in the beginning I couldn't just cursor around anywhere inside the file wherever I wanted to. I couldn't make arbitrary edits wherever I wanted. You still had to go to line 53 and ask it to insert something at column 12. And as time went on, we figured out what was possible with the new technology that was not possible with the old. You could type anywhere you wanted and move around in a file. You could change the color of text in order to tell you if something is a variable or a function or whatever. Later on, we figured out that it's really nice when the editor completes your variable names for you. All this stuff was possible on the first day that the CRT existed, right? We just didn't know how to use this new tech. So we started out using it like the teletypes that came before it. And when graphical displays started to happen, we saw the same transition take place. In the beginning, IDEs were just screen editors inside a window, right? It took some time for us to figure out what this new tech wanted to be used for, right? Sidebars, hovers, red squiggles, annotations, jump to definition, indentation guides. It took time for us to discover all of these things. And even though AI isn't exactly a new display technology, I'd say that it's another one of these fundamental technological shifts. So just like the teletype, the CRT, and the graphical display, there's stuff that could exist with AI today, but we haven't discovered it yet. So now we're in this part of the cycle where we bolt this new tech onto the old tech, usually in the shape of chat interfaces, because it's relatively easy, right? And because the models are naturally good at the whole conversational prompt and response thing. So hello, my name's Idan. And I work on the future of developer tooling at GitHub on a research team called GitHub Next. We're the team that originally created Copilot and a whole bunch of stuff since then. Our job is to figure out how to make software development faster, safer, easier, more accessible for all developers. And last year, I gave a talk that looked backwards on the mechanisms that we've already found for building AI applications for developers. Copilot became a success for developers on the back of Ghost Text. And chat helped popularize AI for literally everyone. But today, I'm going to be looking forward a bit and thinking about the kinds of things that we'll need to figure out in order to reach for tools that are AI native. One of the key problems with AI today is predictability, right? We're used to computers being perfectly consistent, right? 2 plus 2 is always going to equal 4 no matter how many times you compute it. But the models are inherently non-deterministic. Every time we ask the models for something, we're pulling the handle on a slot machine. Now, the models are getting better, so in practice, the odds that our slot machine gives us something good are improving. But to date, we've only been playing the low-stakes slot machine because we're only asking them to generate a little bit, like a few lines of code, maybe a function. But if we try to ask the models for something bigger, like implement an entire feature or fix this bug for me, the chances that we get back something good become pretty slim. So effectively, there's a ceiling on suggestion size. Above it, it's like blackjack. You go too far, you're going to get back hot garbage. And it's not to say that it's easy to reliably generate something good that is a line of code or a few lines, but generating an entire pull request is a very different kind of task. It's more code, but to implement a feature or fix a bug, you're probably going to need to touch files all over the code base, right? Not just the file that you're editing right now. Or maybe you're using your phone. There's no editor. There's no file I'm in right now. I can't actually use that as context. So yeah. And the kind of instructions that we want to be able to give the models are full of ambiguous natural language. And we don't want to have to tell the models where to look in the code base in order to get the job done. Even if the compute takes time, we want to be able to ask the computer, like, fix the bug, go eat lunch, come back, and there's a solution that happened with no supervision. That's the future, right? But the technology isn't there yet. If we want something that isn't a gamble, we still need to steer a little. If we're going to ask the human operator to supervise, how do we make it cheap and easy for the human and good for the model? Unfortunately, the request-response cycle is indivisible. It's a unit. You send out your prompt and you get something back. You can't steer anything in the middle. So there's only 2 real levers for us to pull. You can try to craft a better prompt before you send it, or you can chain a few round trips together and try to do something smart in between those round trips. And for the last few years, almost all the attention has been on the first lever, right? Prompt crafting. And so there's 1,000 blog posts about which incantations you have to utter in order to get the models to reliably cough up some useful response. And 1,000 strategies for choosing what information is most valuable to send to a model, because the context windows are so small. Even though they're growing all the time, there's still, like, you have to choose who gets to, like, stay on the island and who gets voted off. I don't believe that we're going to break the suggestion ceiling only using that first lever. Good prompts matter, and they're going to continue to matter, but there's only so much that we can accomplish in one round trip. Jumping straight from prompt to code was a viable strategy for generating a little bit. For larger scales, we have to find a way to steer, and so many round trips. Now, chat is excellent. It's an excellent modality for talking things over, and it's gotten better at retaining context across round trips. And there are some emerging UI patterns about how to move the code I'm working on into chat and how to move results of my chat back into code. But otherwise, chat has no predictable structure or process. So in the past few months, GitHub Next has been thinking a lot about how to use multiple round trips to create a steerable process. It doesn't start in any particular file. Instead, we're going to be doing sort of these multiple round trips, and the human can see and edit the intermediate thing that happens before every round trip. And if you happen to see the keynotes from GitHub Universe last November, this was teased as Copilot workspaces, and I'm going to sort of take you on a tour behind the scenes of how it works. It starts with a query, right? You ask the models to describe the current behavior of something. This phase alone can be multiple round trips. For example, I write a query, and then I'm going to round trip once in order to figure out what parts of my code base are even relevant to this query, right? Which files might I want to include as context? That might be one round trip on its own. And then the second round trip will be, I'm going to send my query along with the chosen content. And the result is usually something like a bullet point list which describes the behavior that you asked about, that you queried. And this mirrors how developers work, right? Before you can alter a system, you have to identify all the places where that system is doing work and understand what work is being done there. So say I have a login flow for my website. Here it might say something like, when the user visits the login page, render the login form, and when they submit the login form, check the password, and if it's correct, then send them on their way, and if it's not correct, then show an error message, right? That might be the spec that I get back from a query that's just like, what's my authentication flow? But the spec itself is actually a great place to describe the changes that you want to make to how the system works. Say you want to implement and I forgot my password flow, right? You can edit that spec that's generated in place, not only to clarify to the models how it works right now, but also to describe how you want it to be. And so once you're happy with all the alterations to that spec, you submit it. So this is now like another round trip. And we come up with a plan to describe what needs to happen in order to make the change that you asked for. And this is now the second point of control for the user, because the plan itself is editable too. Maybe there's some edge case that the model didn't realize it would need to handle. Or maybe there's some other guidance that you want to be able to give, which will help the model do a good job of giving you code that does what you expect. So by the time that we generate a diff, we've got a clear idea of the code we have to touch. The developer has had a chance to steer both the description of what exists and what should exist, as well as the plan for how to make that happen. And if you think about it, this approach also generates exactly the kind of information that we would need in order to generate tests that verify that the desired behavior works the way that we expect it to. But on the flip side, if things are not going in the direction you want, if the model is giving you back something that's like, oh, it's not quite right, you can go back a step and tweak it. You don't have to back out all the way and roll the dice from zero, because each step builds on the last one. So it's not just steerable, it's incremental. Now, it's not a guarantee that the result is going to be perfect, right? We're not expecting the models to just guess what we want with their psychic powers, and we're not having a theoretical discussion with them either. If we're looking to break through the suggestion ceiling, there's a Goldilocks pattern in the middle, which enables the models to be actionable but still supervised, so that you aren't creating like a hot mess for somebody to have to review later. Of course, it would be even better if we didn't need to do all of this steering, if we could just write a spec in English that describes an entire program and get a working app. We tried that too. The tech isn't really reliable enough yet to be a general purpose tool. We were able to get it to work in constrained scenarios. In the prototypes that we tried, we wrote a Hacker News reader app for mobile devices using React Native with one plain English spec file. We would edit the spec and the app rebuilds live. And this actually worked. And it feels like the future. And at the rate that the models are improving, this is probably closer to being reality than it seems from today. I mean, think about it. A year ago, chat was released. Look how much has happened in the past year. But it also feels a little uncomfortable, right? Because for as long as there have been computers, we've had to give them very precise instructions. And we've invented all these programming languages for expressing these very precise instructions. Why would we want a piece of software interfering in the middle of that? The truth is that developers who write in languages that are, even ones that are very close to the metal, are still relying on a piece of software that's translating what they're writing into something that runs. So I think that there's some discomfort now that's going to go away. Like when the cloud was new, everybody was concerned about renting a shared machine, and now banks run in the cloud, right? I develop mostly front-end things in JavaScript, and I have 29 tools that sit between me and the machine. They're transforming the code, they're interpreting the code, they're optimizing the code. The last time that I looked at the output of any compiler was when I was in college. And that was when dinosaurs roamed the earth. So adding one more transformation layer to the stack is not that far-fetched. Coding in natural language is coming. Not today, but soon. And if it works, it might encourage a style to a more modular style, shift to a more modular style of programming, where we have a tree of specifications which define the different subsystems in a larger piece of software. This is coming sooner than we think. I think this has some really interesting implications for how code editors are going to look in a few years. Looking forward, the space in which we write code isn't only going to be about tasks or even really entirely about code. One of the prototypes that we built a little while back was the Copilot CLI. Like, if I want to execute some command on the terminal and I don't remember all of the different options and flags, I type what I want the command to do, the model produces the command that I want, and it can even explain all those pesky flags for me. It's super handy. But there's no real reason that this interaction needs to be linear. What if it could happen side by side in real time? I think the first time I saw like the closest cousin to this pattern, I saw in a fantastic app for the Mac called Solver. It's like a calculator app. You type your formulas in on one side, and it just live updates the results of the calculation on the other. Now, chat launched a year ago, and it chose to go with a linear chat over this sort of side-by-side UX. And that makes sense because most of the time when I'm using chat, I type a little bit and the model responds with a lot, right? The responses are way longer. But that forces us, when we need to iterate, when we need to fix what was said, or if there's been some misunderstanding, to iterate through more conversation. Like if the model misunderstood me, I don't edit my previous thing in place. Instead, I have to add a new message to clarify the old one. Like, no, I was talking about Paris in Texas, not Paris in France. But using AI as a partner actually opens the door to making interfaces that let us express what we want in whatever way is best for us in the moment. Maybe we want to start by describing the behavior in natural language, or maybe we want to start by writing code. The AI translates one to the other live, so we can check that what comes out is what we expected, and we can refine in place on either side of this sort of magic mirror. Like I can type code and I automatically see what the machine understands that code to be in English. Or I can edit then the English and it's going to be reflected back into the code. I think this is a very powerful pattern, and a lot of the things that we're exploring are interfaces around this sort of pattern. When you hold all this stuff out at arm's length, it starts to look a little bit like Donald Knuth's dream of literate programming, where code comes with an equal amount of prose describing the code. And the rise of notebook-style programming, particularly in Python and sort of the data community, is contributing to this trend. But the reality is that writing documentation, even this kind of documentation, is work, right? What happens when we can have it for free? What happens not just when we can have it for free, but when you can assume that all of the code ever written in the world just comes with this kind of description always? What if it's not just natural language encode? What if I want to think about my code in the form of a block diagram, and I want to edit that diagram and have those changes be reflected back into code? Right now, we've been so focused on how AI helps us to write code, but AI is going to deliver an even larger change, in my opinion, to how we read and understand code. And that matters because when you actually think about the work of software development, reading code is a much bigger part of the job than writing code. I'll close with one more area that I think is important to the future of AI native user experiences for software developers. In principle, this statement is true. I've probably seen every futuristic editor prototype that promised a revolution with like fancy graphics and like nodes and wires and like a visual whatever, but they've all remained prototypes. At the end of the day, when I'm building things, and everybody I've ever seen building things is still working in an editor. Monospaced letters on a grid is how all of us still experience code. I mean, mostly, right? Graphical editors have found a lot of ways to display more information next to the code, above the code, underneath the code, whatever. they've found a lot of ways to layer more information onto the code itself, more meaning. But the problem is that there's a limit to how much crap you can show before you overwhelm the human with potential information. Either way, though, the text on the grid is going to be there, right? That's definitely always going to be there. So one of the projects we did last year doesn't look like it has anything at all to do with AI or the future of software. We went and designed a special set of typefaces for code. It's 5 different fonts that look very different, but which have exactly the same metrics, so you can mix and match them together. If all we have are letters on a grid, how can we use those letters, not the color, not decorations around them, to layer more information onto code? We're already using the color, the weight, italics, underlines for syntax highlighting. So if we want to add more information, we need a more expressive set of letters to show on the grid. And so that's why we went on this adventure. What if we could use a more authoritative looking face to denote authoritative documentation? What if we could tell those apart from the to-dos and comments that we write for ourselves throughout our code? We're all excited about real-time multiplayer coding experiences. What if I typed in my font and you type in your font, and we can tell each other's code apart as we're building things? What if the text coming from AI looked mechanical? What if I could turn on a filter that showed me what parts of my code were authored by humans and what wasn't? There are a lot of really great fonts for code out there, but none of them actually work with one another because they all have slightly different metrics, so they can't fit into the same grid. And that means that no editor has ever implemented these kinds of behaviors because there was never type to support these kinds of behaviors. So we've released these fonts, and you can download them and use any one of them today, but no editor supports these applications yet. I think the important lesson to take away here is that sometimes reaching for the native experiences, these AI native things, is not going to be about more AI. We're not going to get there by just doing AI, but harder. We're going to need to invent some practical stuff that give us the capabilities, that give us the tools we need to reach for the future. Just like these folks who had to invent a whole operating system to create the conditions we take for granted when we develop code. And it was exciting because they had this moment where they could just type to the computer and the computer typed back to them, just like today. Thank you very much.